Ma'am, we are live now.
Okay. Good afternoon, everyone. I, Dr. Narinderjeet Kaur, on behalf of PG Department of Chemistry, Kanya Mahavidyalaya Jalandhar, would like to welcome you all in this one-day workshop on greener and safer chemistry labs. I would like to acknowledge our worthy Madam Principal, Professor Atima Sharma Dwivedi, for always supporting us and encouraging and guiding us for organizing such events. Kanya Mahavidyalaya, the heritage and autonomous institution, is a pioneering institution for women in northern India, conferred with star status by DBT and Curie grant by DST Government of India, and top national rankings by India Today, Outlook Magazine, and Times of India Group year after year. I would like to acknowledge the presence of eminent speaker of the day, Dr. Sonia Ratnani, Associate Professor, Ramjas College, University of Delhi. Welcome, ma'am. Before proceeding further, let's have some glimpses of PG Department of Chemistry, Kanya Mahavidyalaya. So I'm sharing a small video with all of you. Thank you, everyone. The aim of the workshop is to aware the faculty and students of chemistry about the safety measures to be adopted in the labs and the innovative strategies that can be adopted for greener and safer experimental procedures. This talk gives a brief about safety protocols to be followed in a chemistry laboratory. In addition, it mentions greener alternatives, routes for conventional experiments performed at UG and PG level. So I would like to invite now Dr. Shikha to formally introduce and welcome eminent speaker of the day. Over to you, Dr. Shikha.
Thank you, Dr. Narinderji. A very good afternoon, one and all. I feel elated to introduce the speaker of the day, Dr. Sonia Ratnani, who is going to deliver her talk on greener and safer chemistry labs. Dr. Sonia is currently working as an associate professor in Department of Chemistry, Ramjas College, University of Delhi. She has more than 15 years of teaching experience. She has contributed as a content writer in various e-lessons for undergraduate teachers as a part of Teachers E-Kit. She has served as an academic counselor for counseling BSc students enrolled in distance learning support centers such as IGNOU, MPOU, etc. She has been a resource person for many workshops on green chemistry and upgrading lab skills in chemistry. Dr. Sonia has published several research articles in national and international journals and co-authored several books in chemistry and laboratory experiments. In 2018, she has also received Faculty Achievement Award for academic contribution by Ramjas College, University of Delhi. Ma'am, it gave us immense pleasure to have you with us as we have been eagerly waiting to hear you. So once again, we welcome you, ma'am, and the platform is yours now. Over to you, ma'am.
Thank you, ma'am. Thank you for your kind words of introduction.
And a very good afternoon to all educators, students, research scholars, and other participants. Now, let me share my screen.
Sorry to interrupt you, Sonia ma'am. Actually, I think you should face your, towards light, because yeah, it is appearing very dark.
Is it better, ma'am, now?
Yeah, it's better now.
Is it better, ma'am?
Yes, ma'am. Now it's very, very much better. Thank you.
I'm not able to share my screen.
Shashi sir, please see.
Let me see.
मैम नीचे ऑप्शन आ रहा होगा आपको उस टाइम.
ठीक है. Is it visible, ma'am?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am. It's visible.
Okay. So the topic of my talk is greener and safer chemistry labs, right? So it's a need of hour because chemistry laboratories, they leave a massive environment footprint. They are not only energy intensive, and they produce incredible amount of waste. So let's be safe and look for greener alternatives. So chemistry laboratory is, we cannot avoid chemistry laboratory because, it helps us, develop skills, and which cannot be, accomplished by teaching theory only. So we cannot work without a laboratory. But we all know that a chemistry laboratory is a hazardous workplace, and if safety precautions and protocols are not followed, then it may lead to many accidents. So safety is the key to accident-free laboratory, and let us see some of the general, rules. First of all, we cannot work in a laboratory without a lab coat. So lab coat is a must, but we must ensure that a lab coat is made up of cotton. It is a full sleeves lab coat, and it should be long enough. So lab coat not only protects us from chemicals, but also protects our inner clothing too. Second is your safety goggles, which should be always worn whenever we are working with chemicals. And gloves are also mandatory because we always deal with corrosive chemicals and toxic chemicals. So these three are a must for a chemistry laboratory. Besides this, your footwear should be such that your entire feet is covered. High heels should be avoided, and sneakers and shoes are recommended in a laboratory. Synthetic fingernails and nail paints are not allowed. You should not come with your nail painted with this nail polish, and the fingernails also should not be synthetic, because if you work with them, these can interact with the chemicals, and then it can lead to inaccurate results. Also, the hair should be tied up properly, because these can again come into contact with chemical sources or heat sources. Also, no jewelry is allowed in the laboratory, because again, these can again come in contact with the chemicals with which you are working. Also, along with the apparel, the conduct in the laboratory is also mandatory. So, whenever we start a laboratory, we give entire 1 lab period to this, instructions and the conduct in the laboratory to the students, that disciplines need to be maintained. There should be no talking on mobile phones. Eating or drinking is not allowed in the laboratory. Even for lab staff, it should be avoided. The students should not be allowed to do experiment on their own. They should only be allowed under the supervision. We should never allow chemicals to be tasted by students, because these chemicals, whether it is simple sodium chloride or glucose also, this should not be tasted, because these again might be contaminated with a spatula, or they must be contaminated with some other chemicals. Also, while pipetting out, the pipette, you should never directly, pipette by the mouth. Instead, a dispenser or a bulb should be used. A burning burner should never be left unattended because of the reasons of the safety. And whenever we do any inorganic preparation or organic preparation, the student should never be allowed any chemicals. They should not take these chemicals in your bag and go back to home. Hands should be regularly washed before and after using the chemicals. So these are the basic, rules to be followed in the laboratory. So this type of loose hair is not allowed. Instead, it should be tied, and the footwear should be such that it covers your entire feet. Instructions should be followed. So students should follow the instructions given by the teachers for every experiment. They should go by procedure and stepwise. Eating and drinking not allowed. Seriousness and alertness should always there be a lab. You should never hose around the lab because it is a very serious place. And whenever there is any spill or accident, it should be notified to the instructors. Again, washing of hands is, it should be done regularly. The student should also be, made aware of the fact that where are these all safety equipment placed? Because whenever there is an emergency, they should know. They should know where a fire extinguisher is kept, where a fire blanket is there, where an eye wash station is there, where you have that safety shower, and where is that first aid kit. So because in any case, if an accident might happen, then they should, rush to these safety equipment, and, first aid response can be given to the affected. Also, whenever you, heat a test tube which has a contents, it should not be pointed towards yourself and towards others, because it may lead to splashes, boils, and explosions. Also, you should never heat a liquid which has a lid, because again the expansion of liquid can take place and it can lead to explosion. Okay. Also, you should never use your bare hands, or hands should not be used. Rather, tongs must be used whenever you want to pick a container which is subjected to any heat source. Never mix any chemicals for fun, because these chemicals when mixed can lead to another chemical which may be dangerous. For example, if you mix acetone and chloroform, it can lead to explosion also. Also, in organic qualitative analysis, we have a preliminary test where a student is supposed to smell the compound and see whether it is a pleasant smelling or whether it is of some peculiar type. So whenever a student is told to, he or she may directly inhale the vapors. So instead, a student should be instructed to use this wafting motion to smell the odor. Otherwise, this test we can avoid it, because unnecessarily the student, by mistake, because if he's not able to smell properly, he can directly inhale. He may inhale the vapors. So in our, our college, we usually avoid this test as in the preliminary test. Okay. Now, next part of this, safety aspect is the safety symbols, which are nothing but these are labels which portray some graphics. These safety symbols are nothing but they are some warning symbols which are designed in such a way that they give you information whether this chemical is hazardous, corrosive, flammable, and these are nothing but they give messages that if this is explosive, what precaution you have to take. If this is flammable, what precaution you have to take. So these are nothing but safety communication tools, and these are made because if you have a prior knowledge of these are all labels which are there on the bottles of the chemicals, and you can reduce the risk of accidents. So students must be made aware of these safety symbols, and let us look at some of them. So this is a symbol with a check mark which indicates that this chemical is safe to use, and usually in this category we find dilute solutions of acid and alkali which are very easy to handle. You have a symbol with this explosion means the substance is an explosive because it contains stored amount of energy and therefore it needs to be handled, very carefully. Then we have a symbol with a flame, which means the chemical or the substance is a flammable and it will catch fire, ignite easily, and therefore it must be handled with care. And the one of the most common solvent is ethanol, which is used almost in all the most of the experiments, and it is a very flammable. So for this, what precaution we did, we try to keep these flammable liquids or chemicals away from the heating sources. We have a label which depicts a circle with the flames. These are oxidizing substance. Again, they have this, they are prone to exothermic reactions and therefore they must be stored in a cool place or some other place. And examples include the ammonium nitrate. This is also a flame, but it is blue in color and it indicates that this chemical is dangerous when wet. For example, sodium, it is always kept in kerosene, and whenever it reacts with atmosphere or water, it reacts violently. So this also is a symbol which indicates that we need to be very careful. Now, this is a symbol which indicates a cylinder, and this includes your gases which are under pressure. So whenever you have this compressed gases, liquefied gases and dissolved gases such as hydrogens, they are also kept separately because high pressure can build up within the cylinders of these gases and they may lead to explosion or injury. Now, concentrated acids, sulfuric acid, we always consider as them corrosive because whenever they spill on the skin, they cause, burns, they cause irritation, they cause itchiness, and therefore, again, we recommend that we should use always gloves to handle them. Bromine is also very corrosive. This is a symbol which has an eye and it denotes an lacrimatory substance. Benzolation is a very common experiment at undergraduate laboratory, and there we use benzoyl chloride, which is your tear causing, and it is also known as tear gas. And whenever we are performing benzolation, we often notice that there are tears in our eyes. So we again tell students to please wear safety glasses while doing benzolation. We have an harmful or irritant substance. This symbol was earlier used, but now we have an exclamation mark for this irritant. And this also cause, sores, blisters on the skin, and they may cause inflammation of the living tissues. Therefore, they need to be used in a very controlled amount, because if the amount exceeds a permissible level, then, it can cause heavy damage to the skin. Now, this is a symbol in which we have skull and bones, and then again, it is very, very toxic, and all your lead, mercury compounds come under this category. They are very poisonous, and they can, if inhaled or swallowed, they can cause respiratory breathing problems. We have a symbol this for narcotic, though we don't encounter in a chemistry lab, but there are chemicals which can induce sleep, and therefore, there again precaution has to be taken while using them. This symbol denotes that the chemical is a danger to the environment and it can contaminate soil and water and cause, pollution, and therefore their disposal should be in a proper way. Again, we have chemicals which are carcinogenic, which cause cancer, and everybody knows benzene, PCl5. They are all carcinogenic substances, and therefore we need to have substitutes. We need to use, substitute for them so that we can, their disaster effects can be prevented. Then we have radioactive substance, but usually we don't again encounter in a chemistry lab because we generally deal with chemicals and we don't have radioactive substances. They are usually in research labs, but still they are very, highly reactive chemicals which may be fatal to the life. We have this symbol for biohazard, which are biological substances which poses a threat to living organism. Again, this is more common in a biochemistry lab, and it includes many microorganisms such as virus, bacteria, etc. Now we have another this aspect, which is MSDS, which is material safety data sheets. Now the safety symbols only gives a warning. They don't provide any details. But a material safety data sheet is a technical document which provides a detailed information on the potential hazards. And these are usually provided by the supplier or the manufacturer. You can also search online also, and it will give you a detailed explanation that how to store a particular chemical, how to handle it, and what emergency procedures we have to take if an accident happens due to that chemical. So material safety data sheet is also equally important. In fact, in NEP, Delhi University syllabus, now, there is a line written in the syllabus that the students must be given, prior handouts for an experiment, so that they can go through the chemicals and they can go through the, MSDS also of the chemicals, and so that they are aware of the potential hazards of that particular chemical. So this is again a very important thing, because unless and until a student is made to know that this chemical is dangerous, this has to be handled like this, he or she will not realize that what will happen if an accident takes place. Now, accidents do happen in laboratory, right? So we need to have this first aid response, and students must be told about this first aid response also, because sometimes the instructor is not there, and so any emergency, if it occurs, the student or the lab staff, they must be aware of this first aid measures. Now, students often work with glass apparatus. They fix a reflux condenser, they work with viscometer, they fix with stalgometer, and during that fixing or holding, they often, there is a breakage of that glassware, and sometimes you have this cuts and bleeds. So immediately that need to be washed with water. We have to pat it dry. We apply a disinfectant. And then if there is no disinfectant, or if the first aid kit is, very far off, you can just, from the reagent shelf, you can take your dilute ferric chloride solution and apply it. And even if you don't have all this, just if alcohol is nearby, you just, wash it with alcohol. So if it is a minor cut, it can be done this way. But if it is a serious cut, we need to stop the bleeding by applying pressure to close the wound. And, the victim, the affected person, must be taken to the doctor immediately. Chemical burns are also, common in the laboratory, because students do perform, experiments where a burner is involved. Like the melting point determination using Gelda's flask, boiling point determination using your distillation, and other preparations which involve heating. So there immediately, if this burn chemical, there is a burn due to a chemical, then it needs to be washed with tap water, followed by ice cold water or ice pack, which is readily available in a refrigerator. And then you can apply suitable antiseptic cream, which is kept in a first aid box, like your betadine, your sulfadiazine, or your burn oil. Now, if you don't have this, then again you have an option. You can, prepare a slurry. How will you prepare a slurry? You will take some water, you will take some sodium chloride, and you mix it, and you prepare a paste or a slurry type mixture, and then you can apply on the affected part. But this is only for your minor burns. But in case of major burns, we need to wash with again tap water, dip in ice cold water, and either the doctor should be called or the victim should be taken to the doctor. Now, fire accidents also happen in the lab whenever a student by mistake is heating the test tube directly, and the test tube contains ethanol. So there may be a fire accident. There may be a fire accident while holding the burner and taking the melting point or the boiling point also. So if the student is not wearing, by mistake is not wearing, or he's not aware and he's not wearing a lab coat, and the fire can catch, the clothes can catch fire. So immediately he should be made to lie down on a floor, and we can use a wet sack or a blanket to cut off the air supply. We need to switch off all the burners, and we should cut off the fire by putting a wire gauze, or you can use sand or water. So this wire gauze and sand should be readily available. Sand should be available in the buckets, and wire gauze is also available in the laboratory. So you can, in case of minor finer, you can just do it with these materials. But in case of major fire, we have to use fire extinguisher, and the know-how of the fire extinguisher should be, should be known to you students as well as the lab staff, because in case of any major accidents, a fire extinguisher can help in disrupting this major fire. Also, we need to leave the lab immediately, and if it is filled with smoke or if it is a major fire, the fire brigade should be called immediately. Now, again, we keep telling students to wear safety goggles, but again, the student says, today I have not brought my safety goggles, I forget. Again, accident can occur, and eye accident is the most serious. So if by chance, the chemical he or she is working with chemicals, and he by mistake again he puts the hands into the eyes, there is an irritation in eye, then he or she need to wash that thoroughly with water, or if an eye station is there, we can use that eye station. And there are chloromycetin capsules also, we can use them. And if there is an acid or alkali in eye, then we should wash thoroughly with water and then 1% boric acid solution. But if by a glass enters the eyes, you need not rub, because if you rub, it will damage the eye more. So it need to be removed, and the doctors need to be consulted immediately. So eye accidents should not happen in the laboratory, and please keep telling your students to wear safety goggles. Now, chemical spills are again the most common, because the students are working with chemicals, and as a chemistry knowledge, I think everybody is. If there is an acidic spill, we can neutralize with this basic compound. So if there is a spill caused by sulfuric acid, nitric acid, or HCl, then we can wash with a saturated solution of sodium bicarbonate, and again with ice cold water. So this sodium bicarbonate saturated solution can be prepared in a beaker and must be available in the lab. So we can also apply later on a disinfectant, dry the skin, and cover with an antiseptic cream. But in case of basic spill, you just need to wash with tap water followed by ice cold, because the dilution will take place, and then you can apply disinfectant, dry the skin, and then apply an antiseptic cream. Now, the most dangerous is the bromine spill. We often, undergraduate or postgraduate laboratory, we often teach this experiment, that is acetylation of, bromination of acetaldehyde, bromination of aniline, bromination of phenol. So there you can have this bromine spill. So bromine spill need to be, can be dealt with by washing with 2% of ammonia solution, and then with ice cold water. And then again wipe gently with glycerin, and then apply antiseptic cream. Please never use water for bromine spill. This is because water can interact with bromine to form HBr, which is your hydrobromic acid, and which may again, lead to cuts on the hands. So whenever there is a bromine spill, either wash with 2% of ammonia solution, or if you don't find anything, just take an ethanol and wash with ethanol. So ethanol is a very good, solvent, and it almost solubilizes all the organic compounds. Now, we always work with chemical and produce. I already stated in the introduction that incredible amount of waste is developed. So that waste, leads to clogging of lab sinks. And if it is thrown like that, it may be eaten by animals and other living organisms. So this chemical waste, it need to be, dealt properly in a proper and a systematic manner. So, but there are chemicals which do not require, proper safety disposable management system. But here, some chemicals which can be drained safely by using large amount of water. They include your inorganic salts, calcium chloride, magnesium sulfate. So if you are working with this, you can drain safely by washing with excess amount of water. But if you are dealing with the compounds like antimony, arsenic, lead, mercury, these are all toxic elements. They should never be washed down. Instead, they should be collected in a chemical waste container, which should be properly labeled. So waste solution should always be collected in a properly labeled container. Waste solution means if you are using a mixture of solvents, you can write on that bottle what mixture, what is the composition of that solvent, on what date did you collect it, and later on we can subject that to a distillation. Organic solvents also should be stored separately from halogenated, because I already told you acetone and chloroform should never be mixed together. So halogenated organic solvents and other organic solvents, they need to be segregated and stored separately. We can also use incineration. By heating, we can dispose of some of the waste such as soluble organic waste, paraffin and mineral oil, and halogenated organic solvents. So incineration is also one of the methods for disposing of the waste. Also, the waste acid alkali solutions must be stored in different containers, because again, acid alkali, if you mix the waste, you will get a salt. So they should always be stored in a different container. We often do filtration using normal filter paper and Wattman paper. And what do students do? They just throw them in a waste bin. Do not allow the students to throw this. Instead, you put them in a pit for biodegradation, because these are papers and then they can be degraded. Another aspect which I will take is your green lab or greener lab. And safety is one of the issues by which we can safety protocols can be followed there. But another thing is, if we adopt some green chemistry techniques and green chemistry protocols, then also it can lead to reduction in waste, and it can lead to safe. It can be safe also. So green chemistry, it aims at designing such processes which either reduce or eliminate your waste, because chemical waste is 100% hazardous. So by adopting this green methodology or protocols, we can reduce waste. Moreover, it is energy efficient, cost effective. It poses less of hazards and risk also. So green chemistry also reduces chemical accidents. These are all basic principle of given in the green chemistry. So this reduces chemical accidents, reduces pollution, reduces waste, and it reduces use of energy and perishable resources. So we need to have some green protocols, and we need to change our conventional routes to greener routes. Also, this is also one of the principles involved in green chemistry. We can follow the 3 R's in a chemistry laboratory: reduce, reuse, and recycle. So instead of using concentrated solution, go for dilute solutions wherever possible. Work with smaller amounts, milligrams or ml. We should always, ask a student to work in groups and pairs. This also, reduces the consumption of chemicals, and also leads to, reduction in waste. And it also builds a, sense of teamwork. We also try to use waste generated in an experiment effectively. Product of one experiment can be used for another experiment instead of just throwing in a dustbin. So let us see how can we reduce. We can reduce by using minimal amount of chemicals or reagents. All preparations should involve either 1 gram or 1 ml of the starting material. So either you should take, if it is a liquid, 1 ml, or if it is a solid, then you should start with 1 gram. Qualitative organic and inorganic analysis. You should always encourage students, and please try to have the semi-micro analysis kit or group tiles, where again we use less of reagent and chemicals. Spot tests should be encouraged, because again these ensure the use of minimum amount of reagent. And these spot tests, it can be carried on filter paper, it can be on group tile, and it can also be carried on a cotton cloth. Reuse. Now reduce, I have told you, reuse. How can we reuse? The organic preparation should be collected in a bottle and that can be given for exercises for recrystallization, melting point, extra element, functional group detection. So whatever organic preparation is done in a particular, semester or year, that can be utilized for some other semester or year. Because these exercises, recrystallization, melting point, extra element, functional group detection are at, first semester or first year, and the preparation goes in the second semester or the second year. Single step preparation can be used for multi-step preparation. And if you have a product of one preparation, that can be used for multi-step preparation. Inorganic salt, if prepared, you can give the students for mixture analysis, cation or anion analysis. If there are unused inorganic solutions in a titration, they can be reused in other batches for titration, because we usually, tell students to work in batches. So today the first batch has come and tomorrow the second batch will come. So whatever is left in the first batch need not throw and can be reused. Leftover standard solution can also be collected from the entire class and can be given as unknown solutions for the next batch. So if the class has told ma'am itna solution bach gaya, itna ho gaya, then that can be collected and that can be given as unknown, and they can find the what you call normality or molarity of that solution. So this reduce and reuse came into your mind, and I this paper was I wrote a paper and this was accepted in Resonance, applying reuse and reduce in an undergraduate organic laboratory sustainable practices in Resonance, which is a journal of science education. So in this paper, I have given some illustrations whereby some organic preparation can be reused and thereby we can reduce the cost. So what we have illustrated in paper, I will give you an example. Other examples are there in the entire paper. So nitrobenzene on nitrations, everybody knows it gives meta-dinitrobenzene. So it is a common undergraduate laboratory experiment where we use this mixture of acids and we prepare meta-dinitrobenzene as a yellow solid, we get it. Now this meta-dinitrobenzene, once prepared, we can use for the preparation of meta-nitroaniline, which is again an exercise at undergraduate and a PG level. So meta-nitrobenzene is subjected to selective reduction using selective reducing agent, sodium hydrogen sulfide or sodium polysulfide, and one of the NO2 groups can be reduced to NH2 and we get meta-nitroaniline. Now this meta-nitroaniline we can prepare by using this meta-dinitrobenzene, which has been prepared by the students. We can collect in a bottle and then we can prepare it, meta-nitroaniline from this meta-dinitrobenzene. Then we can give this solid meta-nitrobenzene as an exercise to our first year students for melting point determination. Ki ye banaya hai, and please find out the melting point of this compound. We can also give this before melting point. We can also tell the students that please perform a recrystallization exercise, and thereby we train students for this recrystallization exercise also. So recrystallization exercise can also be given using this meta-dinitrobenzene. We can also use this compound and tell students, please identify the functional group in this compound, and everybody knows there is a nitro-functional group. Also, this entire compound can also be given in the qualitative analysis of organic compound, right? So we have a qualitative analysis in the third year, and we tell students that this is a compound. Now you have to identify which compound is this. So we have reused meta-dinitrobenzene in so many ways. Now, what is the benefit of this? In our college, we used to order 2 bottles of meta-dinitrobenzene every year. And they are purchased for this much amount. Now it must have increased. Now this purchase we can avoid, or we can, instead of 2 bottles, we can order 1 bottle. So because we already have this prepared meta-dinitrobenzene, which can be subjected to for other exercise, and which will fulfill our purpose also. So in this way, for organic preparation, we can apply this reuse and reduce. Similarly, benzaldehyde can be oxidized to benzoic acid, and that benzoic acid can be again given for melting point determination, recrystallization, identification of functional group, etc. That can also be used for preparation of benzamide. Similarly, aniline can be undergo acetylation to form acetonite, to form parabromoacetonite, and there also we can reuse and use for many other purposes. So after reuse, we have recycled. So organic solvents, if left in old bottles, they can be distilled, and chemicals also, they can be recrystallized rather than discarding them in trash. And I told you about metadinitrobenzene, which we prepared, we can recrystallize it. And we should not throw any plastic or broken glass apparatus and bottles in the dustbin. Rather, we should store separately, and they can be given further for recycling. Now, we can also have some greener, alternatives for conventional experiments, and they are safe also. And they, again, I'm saying they lead to a high atomic economy also, and they are lead to less of wastage, and they consume less of chemicals. Let us see now. Melting point determination, still in some colleges, they use the sulfuric acid for determining this melting point, but sulfuric acid is again corrosive. So we tell the students not to use no more sulfuric acid, rather than we should use paraffin oil. Also, the thermometer used should be an alcohol based, not a mercury based, because if a mercury thermometer breaks, then the mercury spill can occur, and it is very dangerous spill, because mercury disposal is again a very, very serious problem. We should always tell students to please keep a sand bath to avoid any accident, any spilling, and any accident. So for melting point, these things should be ensured. This is an exercise which is a very common exercise, functional group analysis. This again was published by me and my colleagues in Resonance in 2019, whereby what we did, instead of taking test tubes, we took this groove tile. A groove tile I think we didn't find in a chemistry lab, but I found in a zoology lab. So I got it issued, and then, I thought of doing functional group analysis in this groove tile. So what I did, I took this sodium bicarbonate saturated solution and placed in 1 to 2 grooves. And then I prepared an aqueous solution of the carboxylic acid and placed in these grooves. And then I added sodium bicarbonate solution to this acid, and brisk effervescence was observed, which is a confirmatory test for the carboxylic acid. So this test works well with oxalic acid, succinic acid, phenyl acetic acid, phthalic acid, and benzoic acid. And I think we commonly use these acids. So we can demonstrate also this sodium bicarbonate test on this groove tile, and we can ask students to perform this test on a groove tile, because again, minimum amount of reagent is used, minimum wastage, and it is safe. We are not doing any heating in this experiment. Alcohol also we tested by CAN test, which is your ferric ammonium nitrate test, and you can see we got a red color here. And this test is again was positive for ethanol, isopropanol, benzyl alcohol, and butanol. We performed a ferric chloride test also for phenol. Again, we got colorations for phenol, beta-naphthol, alpha-naphthol, resorcinol, and hydroquinone or quinol. Even the ester test without heating, because normally we, this test is performed in a test tube and we heat it, but we got this at normal temperature or room temperature. So again, this is energy efficient. We performed a Molish test also, carbohydrate test, and even the DNP test was positive. We got a precipitate for most common carbonyl compounds, whether it was ethyl methyl ketone, cyclohexanone, benzaldehyde, benzophenone, and acetophenone. So advantages, you can see reduced consumption of chemicals, toxic and corrosive chemicals we have taken in a very reduced amounts. Cost effective, ensures minimum generation of waste, and thereby it is reducing air and water pollutions. It is also time saving. In fact, you can we can test 3-4 compounds. We can, if a student is given an unknown compound, he can place that unknown compound in 3-4 grooves, and he can add solution. To first group, he can add sodium bicarbonate solution. He can add ferric chloride here. he can add steric ammonium and see which test is coming positive, and he or she will be able to identify functional group in, I think, 5 to 10 minutes. Another most common organic preparation which we do at undergraduate and postgraduate level is acetylation. This is a very important exercise because, you know, acetylation helps in identifying and characterization of organic compounds. Also, you know, we prepare an important drug, your aspirin, via acetylation of salicylic acid. But what are the conventional protocols? We use acetic anhydride, we use acetyl chloride and pyridine, and all are dangerous chemicals. Acetic anhydride is corrosive, irritant, lacrimatory. It also leads to diacetylated products. So when you know, we do acetylation of aniline, both the hydrogens linked to nitrogen get acetylated, and we get, instead of acetylide, we get a diacetylated product. It's costly. It is not readily available because you have to take a special license and a permission for getting acetic anhydride, and it comes under the category of non-green solvent. On the other hand, acetyl chloride, it is always used in combination with pyridine to absorb lead HCl gas, but sometimes we use acetyl chloride alone also. So it is very reactive. It is very difficult to control this acetyl chloride because, you know, it has this good leaving group chloride ion, and it gets hydrolyzed to acetic acid. It is moisture sensitive. It liberates HCl gas. Now, what will happen if it liberates HCl gas? That HCl gas can react with unreacted amine. So if you have aniline, it can react with HCl and you can get anilium ion. So once you get anilium ion, it cannot be further acetylated because the nucleophilicity is lost. So this is a problem with acetyl chloride. And pyridine, if you use it, is highly flammable and skin irritant. So what is an alternative? We can go for green protocols. And the green protocols include acetic acid in presence of zinc dust. Acetic acid, because acetic acid alone cannot be used because you have a poor leaving group there. So in presence of zinc dust, we can use. In presence of trace amount of acid, we can use. In presence of organic acid, also we can use. So this is already, you know, published in a green monograph, and whereby we do acetylation of aniline by a green methodology. We don't take acetyl chloride and acetic anhydride. We take a 50 ml round bottom flask, and we take your 1 ml of aniline, 5 ml of glacial acetic acid, 0.1 grams of zinc dust, and we reflux the contents. After refluxing of 1 to 2 hours, we put the entire concern into a beaker which contains your ice cold water, and we get a white product which is nothing but acetaldehyde. Now this method works for aromatic amines and some phenols, and instead of zinc acetate and zinc chloride can also be employed, and this is all reported in the literature. So instead of using acetic anhydride and acetyl chloride, we can go for this green methodology. So if we use aniline and perform acetylation using acetic acid and zinc dust, we get acetic acid also as a byproduct. And the mechanism says that zinc acetate is initially formed. There is a nucleophilic addition followed by elimination, and this zinc acetate supplies your acetyl group. Now we have this is accepted for publication. This I have tried in my lab, and this has given results for salicylic acid, where I haven't used, you know, zinc dust. But what I did, I took a 100 ml conical flask, and I you know, took 1 gram of salicylic acid. I haven't tried for aniline. I haven't tried for phenols, but I tried for this salicylic acid. So 1 gram of salicylic acid, I took it in a 100 ml conic flask, and I added glacial acetic acid dropwise with continuous swirling of conical flask till I got a clear solution. So salicylic acid solution in acetic acid. Then I added 3-4 drops of sulfuric acid. You can add phosphoric acid, and warm the contents of the conical flask on a water bath, which is maintained at a temperature of 50 to 70 degrees. After this, you have to leave the flask undisturbed for 10 to 15 minutes, and then it was cooled in an ice bath, and we got a white product, and which was characterized as aspirin. You should appreciate, you know, the only byproduct here is water. So there is no wastage. This is a reaction which is a very good high atomic economy. And simply I have used acetic acid, no corrosive acetyl chloride or acetic acid, and traces of sulfuric acid. So this I am still working on, but a part of it has been accepted for publication. This is again one of my work which is published in Organic Preparation and Procedures International, whereby we have this in our curriculum, the synthesis of dibenzyl acetone, which depicts a fundamental aldol reaction, which is taught in 10+2 level. So what we did, we saw at the conventional procedure stage that you take benzaldehyde acetone and you mix them in ethanolic solution, because benzaldehyde is not soluble in water. So benzaldehyde is taken in ethanol, and we add acetone, and then we add NaOH, and we shake it, and then we get this. But we tried to skip off that solvent, and what we did, we used a grinding procedure for this. So grinding procedure, for this grinding procedure, we took this mortar and pestle, and in this mortar, what we added first solid NaOH pellets, 2 gram approximately. Then we added benzaldehyde. Benzaldehyde is taken in excess. You can see 2 moles because we want dibenzyl acetone. So we took benzaldehyde and then we added acetone, and we started grinding for 2 minutes, only 2 minutes. What we found, because this is colorless, this is colorless, this is colorless, we saw a yellow product coming out. This yellow product was extracted with water, and it was characterized and was found by IR, NMR also we did, but at UG level, we don't go for IR, NMR. We told students to perform basic tests. So what we found that it was dibenzyl acetone. So basic test we told students to do. You can do a carbonyl group test. You can do an saturation test for this, and we were able to get a good yield amount, about 76 to 80% using this protocol. So see how we have done this, because we haven't used any solvent, just grinding gave us this product. So advantage of this protocol was reaction. This reaction takes only approximately 10 minutes. This is solvent free. The product isolation is easy. It is a one-pot synthesis, and it is this reaction has a very high atom economy. Now, to conclude, these are the takeaways of my lectures. Please make your students must be aware of all lab safety rules and precautions. They should be equipped with all, your laboratory should be equipped with all safety arrangements. Please, experiments wherever possible, they should be performed with green protocols, because it high time, and we should, change our methodology. We should go something which is very safe and greener. Thank you. Thank you so much.
Thank you so much, ma'am, for your such a knowledgeable and informational talk on the topic, which is the need of the hour. So it was really very nice. So I would like to ask my participants, if you have any query, you can ask directly or write in the chat box. And we will take your queries. But before that, I would like to invite Mrs. Tank Sindarpal for formal vote of thanks. So over to you, Mrs. Sindarpal. You are not able to unmute yourself.
Thank you. Thank you, Narinder ma'am. I heartily thank Dr. Sonia Ratnani for her incisive views on today's national workshop on greener and safer chemistry labs. The session was in sync with the theme of the workshop and perfect amalgamation, citing safety precautions, first aid measures, disposal of chemical waste from chemistry labs. The session also included discussion on greener labs, microanalysis and spot tests for functional groups, and organic qualitative analysis, alternative greener methods, and for common organic preparations for undergraduate students. The session was very well received by our enthusiastic participants, and I assure you, ma'am, that we'll incorporate the suggestions cited today in our regular practicals. We certainly look forward for more such innovative workshops in future. I also thank all the participants for joining the workshop. I hope that this will be an edge over the other, and all the students will follow the safety precautions mentioned today in today's workshop. Thank you.
Thank you so much, Mrs. Tanksinderpal. So now I would request my dear participants, for if you have any queries or you want to ask any questions from the resource person, please you can proceed, or you can write in the chat box. Dipanshu Pandey ji, PPT share nahi hoti hai, so the recorded session is available live on the YouTube, so you can watch this session as many times as you can, right? So any other query if anybody is having? You can unmute yourself. Shashi sir, please see if any participant wants to say something.
Ma'am, right now no hand is raised.
Okay, you can raise your hands. We will. Yes, there is. Shashi sir, please unmute. Chebole.
Yes, ma'am. Yes, ma'am. I have provided the permission to unmute.
Yes, please unmute yourself, sir.
Yeah. Good afternoon, one and all.
Ma'am.
Thank you, ma'am. It's been really very insightful session. You just enlightened us with how to be very cautious and what are the preliminary precaution things we have to maintain during the surroundings of a lab and all. And it's been really very wonderful session, ma'am. Even it's a very new topic for me, but I have learned many things from your knowledgeable session. Thank you for providing us wonderful opportunity for gaining loads of knowledge from this platform. And I also thank our valuable co-hosts and hosts for providing us a wonderful opportunity on this platform to learn. Thank you all.
Good afternoon, madam. Thank you very much for the wonderful session. We need from you to educate us about the disposal of the lab water, wastewater from the lab, which we were expecting very much because we are directly contaminating the environment. Is there any guidances to get more ideas on that?
Yes, sir. Actually, in our college, we are working on this, and there is some system known as safe disposable pit. So, you know, besides our lab, there is a park, and some, you know, work is going related to that safe disposal of water and chemicals. But, you know, for this, I think we need to contact some professionals. And again, this is a need of our, and we must have, you know, sessions also for this disposable. But as of now, you know, for this disposable, we need to have a proper disposable management system. So we are working, and once, you know, I get the details, I will share with you.
Yeah, thank you very much for educating us. We expect this as a separate session, madam.
Sure, sure, sir.
Yes, madam. Thank you.
And thank you, sir, for joining.
Yeah, thank you very much.
Thank you so much. Yes, Dr. Chandana, you want to say something? Please unmute yourself.
Thank you, Sonia ma'am, for your informative sessions. Thank you.
Thank you.
And one query is in the chat box that it is by Professor Manjusha Bhor. Can you please suggest a book for this preparation and nitration of phenol or substituted phenols using calcium nitrate, green approach?
Okay, ma'am. There are many books. There are many, monographs also. But a separate green chemistry books are also there. And I will share. I'm there on the WhatsApp. I will share the details of the WhatsApp.
Yeah, ma'am. Please. Thank you so much.
Okay.
And one request is there. My humble request to all of you to join this Telegram group. No query. This is just. So I think there are no more queries. So if you have, dear participants, if you have any query or any question, you can write in the WhatsApp group also.
Yes.
So our eminent resource person is also there in the group. So
I will share my email ID, etc. also on there, and they can contact through mail also.
Yes, ma'am. Thank you so much, ma'am.
Thank you.
So thank you each and everyone, especially our participants which have participated in this workshop from all over India and even from abroad. So thank you each and everyone, and thank you so much, Sonia ma'am, on
my pleasure, and thanks for giving me an opportunity, ma'am.
Yes, ma'am. So we want to have more collaborations with you in the future also.
Sure. Looking forward. Okay.
Yes. Okay. And before that, I would like to say I'm sharing this screen because it is a festival season. So a very, very happy and prosperous Diwali to all my dear participants and all my dear students, and to all my faculty members, organizing team. Thank you so much. Thank you,
ma'am. Everybody should have a happy and a safe and a green Diwali.
Yes. So you should celebrate this Diwali. It should be eco-friendly and green.
Yes.
Right? So happy Diwali.
Thank you, ma'am.
Thank you so